Yeah, so good to see some people made it back. The sunshine outside I thought would take a few, but look, great to be here, and yeah, I may as well get stuck in. I've got about 25 slides, probably take about 25, maybe half an hour max. So yeah, first of all, I'll talk about my favorite topic myself. No, I jest. Then I'll just talk a bit about the company very quickly, and then we'll just get into the meat of, I guess, a little bit about hybrid cloud, our journey towards hybrid cloud, and how we've implemented that and some of the pitfalls as well. So yeah, a little bit about myself. I'm a Sligo native, BA in computer engineering from UL from back in the year 2000, which tells my age. As Paddy mentioned, after college I went to Galway, worked in what was then Compaq, although everyone was wearing digital t-shirts at the time, and then went through the transition to HP and onwards. But no, got a great foundation there on software engineering, and my background has been really developing software for about 12 years, mainly in financial services sector, before a brief stint in healthcare, and then the last 10 years really working in e-commerce. Moved obviously from technical more into the dark arts of management, which I'm sure to some of you is a bit like going from Gryffindor to Slytherin or something like that. But no, we're not all bad. And yeah, I guess that journey of management and leadership has been a really interesting one. Yeah, so my current role is a vice president of software development with Overstock. I'll tell you a bit about the company. So, unlike the name suggests, you would think, hey, we sell Overstock. That's what they started doing. That was back in 1999. Again, if you, yeah, a lot of you were probably around in 1999, but that was, when I was, yeah, MP3s were a new technology. I was kind of hoovering up MP3s back in college in third year at the time. There was, Yahoo and Alta Vista were the top search engines. So there's a long, I guess, the company's been around a long time. It's re-innovated its business model quite a few times, but kept the name. But what we actually do is we're an e-commerce site, the fourth largest in the US for selling home furnishings. So everything from your kitchen, your bathroom, your bedroom. Obviously, COVID was quite interesting. Everyone was buying home office stuff. Everyone was fitting out their patio. We saw like a large scale up in sales, and that also kind of feeds in again to that whole journey towards hybrid cloud. Kind of realizing, whoa, we weren't even sure were we going to be able to deal with the surge in our data center at the time. A large part of our business is supplier facing, so we were essentially a giant marketplace for suppliers to come and sell their goods on our e-commerce website. So yeah, about 4,000 suppliers. We obviously integrate with them, their warehouse systems, inventory management. We also provide fulfillment services. So we've warehouses dotted across the US that they can use to store their products to be closer to customers. So that's the company. Yeah, the vision, making dream homes come true. So yeah, hybrid cloud. You've probably all been, yeah, what is hybrid cloud? Obviously, it's not multi-cloud, which is using multiple public clouds. It's marrying your own data center, your own compute, your own storage with a public cloud. Obviously, many ways to do this and lots of nuance. A lot of the big public cloud providers are now offering tools to, bring the capabilities of public cloud onto your data center. Things like we've looked at, Google have Anthos, Amazon have got Outposts to kind of, to help bridge that hybrid cloud. We did look at those. We felt cost was maybe prohibitive there. We also had quite a substantial on-prem capabilities built. So we went for a different approach, which I'll go into later. Yeah, I'm sure some of you recognize this guy. You are all individuals. This is not the one way to do it. It's not simple. Hybrid cloud has to be figured out really for yourself based on your business need, your customer need, what your development teams need, what are the missing capabilities. Obviously, cost is a huge factor as well. Very complicated to actually work out your TCO, looking at your data center and comparing it to public cloud. Obviously, CapEx versus OpEx, all that kind of stuff. But yeah, we did a pretty good showback model for our on-prem data center, and then took a look at the public cloud and made some strategic decisions then based on that. So keep tipping along. Yeah, strategy. So really, here's just a couple of things to think about when you are looking at, and again, I'll talk more about moving from having an on-premise private cloud, utilizing public cloud. I know the opposite is also true of, maybe startups scaling up in public cloud, and then, looking to actually, bring some capabilities back into a private cloud. Now, funnily enough, a lot of those examples that I hear come from our data center folk who are finding them and kind of telling us again, because by far the majority is people, looking to move to the cloud off data centers. But really, start with the why when you're looking at your strategy for hybrid cloud. You want to modernize. Maybe you do want to move, fully into the public cloud, but you want to do that at your own pace. Scale into the cloud is something that we definitely wanted to look at. Again, we were, saw a significant rise in business due to external conditions in a positive way, but we're kind of wondering, well, can our data center deal with this? So really accelerated our approach to looking at using the ability to scale up into public cloud. Again, leveraging capabilities not available on premise. There's just no way you can keep up with the speed of the public cloud companies and what they're building and what they're putting out there. So a lot of the time, maybe your teams might, maybe the vast majority of your company development teams, you just need compute and relational storage, etc. But then there's just more and more added value and higher value products being developed on the cloud. So really, that's where we were looking as well towards the cloud. It might be regulatory. Maybe you need to keep data in a certain jurisdiction, for certain customers. Again, cost ROI, location, getting closer to your customers. Again, having data centers across the world with public cloud. And experimentation is another one that's very obvious, where you don't need all that compute, be it, or maybe it's again, ML model training, GPUs. You don't have that on-prem. You don't want to spend all that money on hardware. You just want to scale up, run a large-scale experiment, and then scale down again. So lots of uses, I guess, for why you would start thinking about public cloud or hybrid cloud. Yeah, so for us, this was really why we said we need to go this direction. As I mentioned, sustainable revenue growth. We have looking to scale up, but not wanting to have our data center deal with the peak of traffic. Again, e-commerce being quite a seasonal business, you scale up in the to hit those peaks around, for us it was, Black Friday and Cyber Monday and all those days when, you get your peak traffic. You don't want your full data center always, trying to keep ahead of your business growth. And again, the lead time to get the hardware into the data center. So, we're saying, look, how can we leverage and architect our systems in a way to actually scale off on-prem into public cloud using that kind of elasticity of the cloud. Disaster recovery is another key one for us. So we had Dior built with another data center. Again, quite a manual, I suppose, or quite a complex setup, I suppose, for Dior. But as we started saying, hey, we want to scale into the cloud, let's take a look at also trying to use public cloud for more of our disaster recovery. Again, a 24-year-old company, our analytics was a little bit sharded. Sometimes you'd be hearing in some of the meetings, conflicting reports on certain data sets. And we were just looking at, how do we unify our analytical approach? Maybe we wanted to re-implement, I guess, some of our approach to our analytical data gathering and analytical tools. So we said, does that make sense to do this on-prem, or let's take a look at what's available in the cloud. And again, I'll talk later on about the strategy we went on there, as well as then other capabilities. So we were looking at, again, we built. I didn't talk about, I guess, the capabilities we have in Sligo. We've got a machine learning and ML engineering teams who've built model serving, model training on-prem. And then you're just kind of looking at the way, I guess, the tooling in the cloud is moving so fast. So we said it makes sense to move from on-prem up to the cloud on that. Secondary kind of benefits for us, high availability. As our e-commerce business is growing, we're kind of realizing we want to be able to expand to new geographic regions. Again, not having everything served out of our data center, which is based in the company headquarters, by the way, is in Salt Lake City, with our software development center based in Sligo. But yeah, we didn't want everything coming back to home. And then modernization. Again, we have a certain amount of tech debt. We were modernizing and thinking, well, let's make sure we modernize with the public cloud in mind. Now, some anchors we have when we're looking at this strategy. Data monoliths, obviously, hard to break apart. We've, Oracle instances that are quite tied to our data center, not easy to move. So again, I'll talk a little bit later on about the strategy for dealing with that. So this slide is just kind of showing a little bit of the push-pull, I suppose, when you start adopting public cloud. You've, your business requirements, your development requirements, determining maybe where you want, if you want to run it on-prem or taking a look at public cloud, figuring out patterns and topology around that. But then on the other side of the fence, you do have your operational requirements, your architectural requirements, security kind of pushing back. So there is a bit of a push-pull associated with the cloud adoption when you are in that hybrid model. Or even, in our example, this is probably a bit of a better picture explaining that push-pull. So the developers were, it was like kids in a candy shop when we, offered them to use public cloud services. So they were like, they wanted to get in there. They wanted to learn, play with the fun tools. It was really, let's get in there, hands up, who wants to use public cloud? And then on the other side, obviously, our operations folk, our data center, individuals, the security folk, kind of going, what the hell is going on here? How do we approach this in a more structured way? A lot of concerns kind of pushing back. And I want to talk a bit about that. It's not all about technology. When you have, obviously, your own data center and teams who have a lot of time and pride invested in what they've built and the platforms they've built for your teams, and then you start adopting public cloud. There's often an inherent pushback and drag and a lack of maybe engagement within your organization to adopt public cloud. So that's has to be acknowledged. And I talk a little bit about that. I suppose the model we came up with was getting everybody on board with ownership of public cloud as well as your private cloud. Yeah, so HashiCorp, famous company who have open source Terraform, and behind Terraform, they talk about the phases of cloud adoption. And in my slides, I'm saying, yeah, hey, everyone, you start with your strategy, but the reality is most people don't start with the strategy. It's more a fear of missing out, or somebody comes into the company with public cloud skills. Or you have a new VP comes in who wants to use public cloud. He's used it before in his previous job, and gets buy-off from the CEO, and developer who's really excited just gets empowered to go and start using public cloud, and that's what happened with us too. So Team A is standing up some application in public cloud. Team B is doing something different, all working in isolation, and this is often, as I said, the reality of the way public cloud first gets used, I suppose, within a lot of companies. And yeah, you end up with the virtual equivalent to that server room, which is a real mess. And I can attest to that. We also built our first office in Overstock. Was the software engineers were doing the networking, so we did. That's not my picture, but we did have something a little bit like that too. But yeah, some of the I want to talk about some of the factors on the right, I suppose, that go into, when you are actually using public cloud from a software development and operations point of view. So, if you think of the pre-production, where does your code live? What kind of continuous integration software are you using, or pipeline are you using? Where do your artifacts live? On your on-premise repository, or are you pushing them up into a cloud repository? Be that your jar files, your Docker images, etc. As I mentioned, what pipeline? What's happening in that pipeline? Where's your testing happening? Are you spinning up containers? Are you doing the same type of testing that you used to do on-prem? What about integration testing when you now have a cloud environment in the mix as well as your on-premise environments? What used to work on-prem when you bring in the cloud doesn't work anymore. It changes the paradigm. And then you've got, actual production environment. Well, if you're a public company, maybe you've got SOX compliance where, developers should not have access to, your production environment. There should be a separation of duties there. Who's provisioning the public cloud? Who's actually determining the size of the, what's running, or who's looking after the test environments? Secret management, as was mentioned, where are you putting your security tokens or API keys or all this type of stuff? This is all, it's again, when it's done for you, it's quite simple. When, you're doing this in a more ad hoc basis, maybe every team trying to solve this in a siloed approach, what you find is, it's a real high cognitive load on the team. Some teams, obviously, some software developers, they love this. They love doing everything. The mythical DevOps, I guess, of, which is not obviously developers doing everything, but it slows down your business delivery really, unless you have a more structured approach to how you want to do all those things on the right. And then obviously observability too. So you want to make sure as part of your delivery of value into production, as well as obviously running your software in production, where, dashboarding, alerting, setting suitable thresholds for your service level. All that kind of stuff is, again, a lot of duplication of effort. You end up with cost overruns for hardware being over and provisioned in public cloud. Test environments been spun up and just left running when really, you should be spinning them down. Things like that. And security and compliance. Obviously, Nick gave a fantastic talk on different security aspects. But when you're doing that in a one-by-one basis, it's really risky, and then really hard to undo those mistakes as well that happen. So we, I don't know if anyone knows ClojureScript. We got a whole pile of lambdas running in AWS written by an ex-developer, and we're trying to undo that now and figure out what was going on here. Lots of things like that to consider. So I suppose that's as I mentioned, that's what a lot of companies find themselves, maybe through acquisition, maybe through a VP coming in and just kind of pushing public cloud as a way forward, without really thinking strategically about how you want to, manage your hybrid cloud environment. So this is more of a model that Amazon, I guess I took this from an Amazon AWS white paper, but it's what we've implemented within our company too. So I just want to talk briefly about, I suppose, the bottom right corner there as well, about it's from a book called Team Topologies. I'm sure some of you who are in the development community have drank the Kool-Aid and read the book. But it's about, just different types of development teams that typically are in companies, whether they know it or not. You've got a streamlined team, which is more focused on a value stream. So delivering what you call a product team, delivering features directly to a customer, be that external or internal. You've also got an enabling team, which would be a team that's there to support those streamlined teams, bring them a different technical capability or an expertise that they wouldn't have. And you've got the idea of a platform team as well, which is, again, a team within your company that's building an application, a suite, a set of self-service tools for your streamlined teams to use. So this kind of cloud operation model is really about looking at public cloud, and again taking a platform approach, making sure each team is not trying to figure this out itself. You've got a platform that's built to help manage your teams use public cloud. On top of that, you've got what's called a cloud operations and platform enablement team. I'm going to talk a bit more about that team after this. But that, again, it's an enablement team there to support those teams who want to adopt public cloud, that will help them demystify it, form a bit of a paved path and make sure that they're engaging with the platform engineering to make sure that the platform that's built to use public cloud will suit the needs of the engineering teams. And ways to do this, I suppose, there's obviously those of you who would have used, infrastructure as code, Terraform and Terraform pipelining is one way to do this. Another is, using things like CloudFormation stack, or even like Amazon and GCP will be the two I'll be most familiar with. You can have a service catalog where instead of opening up all the applications that are available on public cloud to all your teams, you curate a set of applications or a suite that you then make available to your team. So you're kind of just narrowing again the focus of what you want your teams using in public cloud, and just reducing that overall footprint. Often you'll find as well escape hatches kind of for something that those teams that really are pushing the boundaries, that don't really want to wait for your platform to maybe be built out. You can kind of put a review process in place that as they want to use public cloud, you just have a review process in using this COPE team to kind of just make sure that what they're doing fits in with the direction of everybody. So yeah. The Cloud Operations Platform Enablement team that we built really consists of, all these different teams within our organization. So network engineering are on there, have a representation on there, security team, the storage team, data engineering and data governance, our database administrators, DPO, which is the name we have for our data streaming kind of technology team, our enterprise data warehouse, our site reliability engineering team, and then the users, I suppose, the machine learning team and the cloud enablement team, which is kind of representing the developers' needs. So the idea is that each of these teams essentially owns, when you go with infrastructure as code, owns a part. So you federate your infrastructure as code into different modules, and you give each of these then a different ownership over how the network is built out in public cloud. So, your dev teams don't need to worry about that. That's already done. Your security is taken care of, your storage, and your database. You don't really want your developers trying to configure the database backups. Does the data need to be encrypted? So by, I guess, taking this enablement team approach and using a kind of a layered infrastructure as code approach, you can make it reduce the cognitive load for your dev teams. So they really only have a couple of decisions to make when it comes to provisioning applications in the public cloud. So you got the idea of, I guess, a base platform. And for us, again, talking about trying to change culture within the company, we made sure that we empowered, or we gave responsibility for that platform, that deployment platform for public cloud, to the team that owned the deployment platform on-prem. So, there wasn't this kind of a conflict or a sense of, not sort of them, I guess, between, empower your teams to own, your existing teams that own your data center, that own your private cloud, to own their same responsibilities in public cloud. I'm not going too fast, am I? Is everyone, it's all good? So we'll keep moving. And then look, phase 3 really is getting towards homogeny. So really, you don't want, again, using that term, cognitive load, you don't really want too much cognitive load in your teams. You want, if your team is just looking for deploy Spring Boot application with a data store, you want that to be quite simple and not have, am I deploying here, am I deploying here? Reduce the cognitive load there, simplify options. Again, I'll talk a bit later about architecting portable workloads, making sure that when you do build your code, that it will work, I guess, on-prem or in the cloud. And really that's a whole, obviously with containerization and Kubernetes, it's made life a lot easier in that regard. So that's, look, I'll go on now to more, really what you want to do is make sure you have clear boundaries and clear ownership over use of public cloud to make sure you get something like a Zen garden rather than something like this overgrown garden, which actually doesn't look that bad, but yeah, you get the picture, you get what I mean. So I'll talk a little bit about our own journey, I suppose, Overstock's journey, and a bit more detail on some decisions we made around what workloads should stay on-prem and what goes to public cloud. So yeah, Overstock, we have basically an OpenStack based private cloud. So OpenStack is kind of open source software for managing your data center. Prior to 2017, we would have deployed using Red Hat Package Manager. So packaged up all our code into an RPM. We would have used Jira, a ticketing system, to put in all the details that this software has been tested and signed off, and then twice a day the code would have been deployed onto our on-prem environment using Jenkins infrastructure. And we still have about 500 applications that are deployed that way. And then in 2017, we came in and basically built Kubernetes on top of OpenStack within our own data center, and had some pretty opinionated architects at the time that said, you don't need test environments. CI/CD, deploy straight to production is the way to go. Which it's good if you can do that, but you do need test environments still. Just to say that. So we've had to re-architect to make sure, as part of our deploy, you can still deploy through test environments. But what we did see was an explosion in microservices, and the barrier to create a service actually became so low that we've almost got too many applications now, if I'm honest. So we have 700 applications. Again, some of those are web services, some would be just simple consumers or producers, all Dockerized and all running in our Kubernetes environment on premise. So, and then what we've done with this then is, I suppose, enable the very same deploy pipeline that we use to deploy onto Kubernetes can now deploy straight onto Google's Kubernetes GKE up on public cloud. Again, there is a program I'll talk about how we had to make sure all our applications would run on either of those environments. So some other details here. Again, we have had a large Teradata, that was our enterprise data warehouse on-prem, as well as Hadoop cluster. Apache Pulsar is our messaging framework. Again, it's very similar to Kafka for those of you who would have used that. And then an Oracle RAC install, which is Oracle-based hardware on-prem, and an Oracle ERP system. So these are all kind of the Oracle systems very much are kind of in our data center and quite tied to our data center. Hard to kind of they're kind of anchors, I suppose, keeping us there. And then we also have Postgres running on Kubernetes, which again is a nice way to do microservices when you have your applications can run in Kubernetes and your database can run in Kubernetes also. It makes it, again, very, very portable for shifting those workloads into public cloud, as well as a Cassandra NoSQL environment. So yeah, here's just some numbers. We've got, I won't read them all, but yeah, about 7,500 CPU cores with 52 terabytes of memory powering about 2,000 VMs. That's just in our production environment. And then, as mentioned on the Kubernetes side, about 900 deployments per month. And there's actually been about 50,000 deployments, since it was launched. So yeah, it's really nice to be able to, I guess, deploy that quickly with an on-prem environment, and then again having that containerized approach and trying to build those same pipelines to deploy to public cloud, and then test. Yeah, we've a separate OpenStack cloud, less hardware, more environments for testing on. So as mentioned, when we went with our first approach to cloud, it was very much our marketing department, which is responsible for obviously attracting customers onto the website. We had a VP who just had experience in a previous company using public cloud, and he just kind of gave the go-ahead to all the teams to start using public cloud, and it was a little bit chaotic. Great in one way, but as I said, we're paying the price now of trying to undo some of that work. So yeah, there's kind of a bit of a lack of strategy, really, is to say, well, what should be up there, what should be back on-prem. So in the last two years, really, we took a more strategic approach. So we sat down and said, well, look, let's look at our workloads. We signed a strategic agreement with Google to partner and use GCP. We kind of published a cloud strategy, I suppose, that I went through earlier on with you guys, kind of illustrating, why do we want to use public cloud? As the main benefit was, scalable, business really to make sure we weren't constrained by the current hardware in our data center as we wanted to kind of grow our business. And again, really enabling tools that were available up in public cloud that we didn't have on-prem, not to allow our business to move faster. We formed that COPE team. We recognized the anchors that were kind of tying us to our data center and formed a strategy as well to say, well, how can we maybe even move past some of those anchors? So I'll talk a little bit about that as well. Analyzed our workloads, figured out, when we are deploying to public cloud, obviously, we need reports to see cost. We need to tag what is going up into public cloud and able to see so we can attribute that back to the business, the cost centers. So there's not like a cost overrun or cost. We think about cost management up front. And then also, enable those early adopters that really want to maybe break through and use the cloud a little bit more quicker, have some kind of review process there. From an architectural point of view, obviously in my background, software engineering, you got to get used to the concept of event-driven, eventually consistent architecture as well. So, when you have data in your data center, but you want to start leveraging public cloud, you got to get used to maybe, having the data been event-driven and syncing up into different data stores in public cloud and being eventually consistent and not relying on too much, coupling between your systems. So one approach we did is taking a leap from domain-driven design is kind of identifying all your business domains and then, looking at your architecture from a domain point of view and then kind of recognizing that maybe a domain could be shifted up into public cloud or a domain should remain on private cloud, but then not breaking, any given business domain across those boundaries. And a kind of program I've been championing myself or driving is the app modernization program. So that was really looking at all our applications, getting the development teams to, some automation there, but actually just to analyze the applications against a series of criteria to see are they suitable to run up in public cloud. I have a slide talking briefly on that later on. How am I doing for time? Doing okay. One other thing we did when it comes to networking, so as I said, we formed a partnership with Google. We have our data centers in Salt Lake City. They have a data center in Salt Lake City. We actually built a dedicated fiber link between the two data centers. We then formed a shared VPC network between our data center and one of Google's Salt Lake data center. And then we built software into that platform that when you want to create a project, a test project or a production project, it essentially just spun up that project and the networking was all taken care of. There was no more going to the network engineering team, looking at punching a hole through your web application firewall, looking at egress and ingress rules. It was all kind of taken care of within this shared VPC model. So that's a nice one to kind of think about if you can. Obviously, not everybody's going to have the luxury of having their data center and being able to do that, but it kind of we ended up doing quite a bit of performance testing as well, and I guess our applications that were we did some tests, running on our running up in GKE and Google Kubernetes, talking back to a database in our data center. We only saw roughly a 4% increase in performance at the P95 level, which would be at the 95th percentile of performance, the outer performance, which is pretty good. So it means we can actually scale up from on-prem on our Kubernetes environment into Google's Kubernetes environment, reducing the need for a lot of extra capacity in our data center. So for us, the workloads that we figured were more suitable for public cloud was, as I mentioned, we looked at our data warehouse that was on-prem, and as I mentioned, we were using different reports and different tools, and we actually partnered with Google again and did a full migration of all our analytical our data warehouse up into Google's BigQuery, and then we've started migrating a lot of those reports from our old reporting tools up into Looker, which again, I'm not selling Google, let's say Microsoft and Amazon have all the very same tools, but it's just a more self-service approach to analytics. And the way we felt about it is, look, if we're going to move our transactional systems are very much anchored to our on-prem, through Oracle, but our analytical data that we can feed up into the cloud, it actually makes more sense up there. There's a lot more tools that we won't be able to, maybe build out as well in our data center. Another, some applications that we actually shifted to public cloud were, so in e-commerce you send a lot of emails. I'm sure you guys get spammed all the time by e-commerce providers. So, we tend to sell now coupons. We tend to send promotional emails out to our customers. And then when they click on those emails, there's a surge of traffic because we personalize those emails. It calls back and we render a personalized email for each person. And that will always cause problems in our data center because there was large traffic spikes every time the email sends went out. So we figured that's a workload that's suitable to move instead to public cloud that can just surge up and scale up as needed, and then drop down again. You don't need that level of on-prem capacity to deal with those workloads. Traffic spikes, as I mentioned, those real heavy e-commerce days, and other workloads that are more suitable for serverless, things like cron, time jobs, batch jobs, things like that. As well as our machine learning teams, so doing model training. We were building out a feature store, which is kind of what you present to your machine learning scientists to kind of try to do all the fun stuff there around figuring out I guess models to build, etc. And the model serving, actually serving up those models in real time. And another capability that we're using up in GCP is it's a vector search engine called the matching engine that's part of Google's offering. Again, to try to do that on-prem, or to try to get that set up and manage that and run that, it just didn't make sense for us. So these were kind of some of our workloads we decided that should be running up in the cloud as opposed to in our own data center. Yeah, I think I've covered some of these. So we've migrated our Teradata data warehouse up to BigQuery, migrated a lot of our dashboards up to Looker. We are migrating our on-prem Hadoop cluster up into Dataproc, which is an equivalent up in the cloud, to do your data analysis and ETL jobs in real time data streaming. Our ML stuff we're moving up to Vertex AI, which is again Google's kind of suite of ML tools in the cloud, and our on-prem messaging Apache Pulsar. We had it kind of deployed using we didn't basically use the Kubernetes version, so we've kind of upgraded that on-prem to run on Kubernetes, and then that again becomes portable to run up in the cloud or on-premise. Getting towards the end. Am I only going 12 minutes? Maybe I'm flying through this presentation. Not to worry. We can have Q&A, plenty of Q&A if you want, or I can go back over anything. App modernization is the program I mentioned to try to modernize our apps, make sure that the work we did can run, that the applications can run on-prem or in the cloud. So part of that was migrating off Oracle to Postgres, which is not a simple thing. But what we did is as I said, we got the teams to analyze. Here's just a graph showing the level of effort required across each team to modernize their apps. So we just used Excel. We created, put all our applications into Excel. We got our teams to grade, yes, no, based on certain criteria. Aggregated that data then by team, by category, so we saw just how much work it would take to modernize our applications to make them more cloud native. I mentioned already, taking more of an event-driven approach, domain-oriented approach to your architecture. There's obviously lots of good documentation around, the concept of a 12-factor app, which is making sure your configuration is not or is externalized. You're not tied to things like a file store on-prem like NFS or anything like that. And again, making sure your application is Dockerized, wrapped in a container. Another good approach is the 5 Rs, which is as you analyze your application to look at its suitability for running in the cloud. Take a critical eye and, does your app just need to be retired? Do you even need this app? Does your app need to be retained. I.e., it's already pretty much ready for the cloud. You just need to maybe create a Docker file and again get it packaged up. Do you need to rehost? Rehost is a concept of, again, rehosting into Kubernetes, but maybe a little bit more work needed there. Or replatform is taking that another step further. Or reimagine is essentially the app is just it's too much. There's too much tech debt there. It's a monolith. It's huge. It's maybe it's running on bare metal. You're just never going to get that running up in the cloud. You need to reimagine it. So what we did is, those of you who are software developers, we signed a kind of a score, a story point, a point associated with each the work needed to modernize the app, and then I guess went through and kind of got a good feel then across of our whole application suite of how much work it takes to modernize the stack, and then working with the product management team then to start chipping away at that work and prioritizing which of the applications that we want to be able to run in public cloud, prioritizing that work. Yeah, and that's pretty much coming towards the end of the presentation. So yeah, really it's about taking a platform approach to public cloud, making sure it's not like a private cloud, public cloud, very, very different, getting shared ownership of both of them with your various teams that have responsibilities, having an enablement team around cloud adoption, again, with various skills, so they know, they're there to advise and to help teams and to demystify if a team comes and says, hey, should I run this on the cloud, or how should this run on the cloud, or should I just keep this on-prem? The concept of the infrastructure as cloud producers, so again, federating that Terraform out to your different team owners, so the networking, the storage, the applications are actually kind of I guess agreed by that cloud enablement team. And then, having a developer-focused enablement team as well, kind of paving the road for your team. So it's not each team trying to figure it out by themselves, and they can represent the development team as well on that COPE committee. I'll finish up by saying simplicity is a prerequisite for reliability, and not just reliability, for security, for delivery of business value. It is about trying to not open up the full, making it complex for your teams when you have, all that overhead of, 2 different deployment environments on-prem, and then you're opening up the whole of the cloud as well. It can be overwhelming. So it's about trying to reduce that window of what you want to use the public cloud for through a strategy, and then approaching that through a more, more smart, I suppose, and simple way. So 17 minutes. You can tell I don't do an awful lot of presentations. I kind of maybe should have taken a few more breaths and maybe given time to pause for you to digest some of that stuff. But that's it for now. And look, thank you for listening. And hopefully some of you took a thing or two from that presentation. I know from chatting outside to some of you during the break that there's obviously a lot of expertise here, a lot of people who can teach me a thing or two about public cloud as well. So I'll be hanging around for a while and want to have a chat with you. So look, I'll open it up for any questions.